Now a relation in terms of R1 plus R2 into R2 plus R3 into R3 plus R1 whole divided by circumradius capital R into R1 R2 plus R2 R3 plus R3 R1. Now the given expression value, that is R1 plus R2 into R2 plus R3 into R3 plus R1 by capital R into R1 R2 plus R2 R3 plus R3 R1. Now the denominator second factor, that is R1 into R2 plus R2 into R3 plus R3 into R1 value is S square, and we will also use the result R1 is delta by S minus A. Similarly R2 is delta by S minus B and R3 is delta by S minus C. Let's carry these two results and substitute in the given expression. Then the given expression becomes delta by S minus A plus delta by S minus B into R2 plus R3, that is delta by S minus B plus delta by S minus C into third factor delta by S minus C plus delta by S minus A whole divided by the circumradius R as it is, but R1 into R2 plus R2 into R3 plus R3 into R1 whose value is S square. Now how is the LCM in the numerator? It is S minus A into S minus B into S minus C, but as we have S square in the denominator, let's take the LCM as the product of all the terms. Then clearly the numerator is delta cube into S minus B plus S minus A into S minus C plus S minus B into S minus A plus S minus C whole divided by R into S square into, as we have taken each term directly up, then we have in the denominator S minus A square into S minus B square into S minus C square. Now delta cube into, look at the first term, this is 2S minus B minus A, so is that value C. Similarly 2S minus C minus B is nothing but A. 2S minus A minus C is nothing but B by R into, what is this, S square into S minus A whole square into S minus B whole square into S minus C whole square. Yes, the value is delta to the power of 4, right? Now cancelling the common factors in both numerator, we are left with ABC by R into delta. But what is ABC by R into delta value? Yes, this value is simply 4. So what is the given expression? R1 plus R2 into R2 plus R3 into R3 plus R1 by R into R1 R2 plus R2 R3 plus R3 R1. The value is 4, which is present at option A.